The next section in chapter 2 that we're going to talk about is section 2.4, early experiments to characterize the atom. So after Dalton, scientists began to wonder about the actual nature of the atom, so they wanted to know more about it and what it was made of and how do atoms of different elements differ. So this there ended up being a lot of experiments to characterize the atom. So the first experiment that we're going to talk about is J.J. Thomson's experiment. So his experiment ended up determining the charge to mass ratio of an electron. So J.J. Thomson was a physicist and he studied electrical discharges. So he was a physicist. He studied electrical discharges in partially evacuated tubes. That he called cathode ray tubes. So he called them cathode ray tubes because the actual beam of particles originated from the negative pole of the electric field. Okay, so this created a beam of particles, and from this experiment, he hypothesized that the array of particles consisted of negatively charged particles. Okay, we now know that these negatively charged particles that he hypothesized about are electrons. So that is what we call them today. So from this, he found the mass to charge ratio of an electron, which is equal to, so E is the mass of the electron, or I'm sorry, the charge of the electron over M. So E is the charge, M is the mass. So this is the charge to mass ratio, and he found that it was equal to negative 1.76 times 10 to the 8th coulombs per gram. Okay. So Thomson also thought that because from this, he thought that all atoms had electrons, but they also need positive particles because they knew at the time that atoms were neutrally charged. So he said that the atoms must contain positive particles that balance the negative charge that's carried by the electrons, because you'd have to have the same number of negatively or positively charged particles as negatively charged particles to get a neutral atom. So this is what his experiment looked like. So he had these electrodes, and this lighter colored part in the middle of the tube is actually the uh, the ray, the stream of negative particles or electrons. And this is a more modern image of what it would look like. So from Thomson's results, Robert Millikan performed some experiments involving charged oil droplets, and he was able to determine the magnitude of the charge on a single electron using Thomson's charge to mass ratio. Okay. So he found that the mass of an electron was 9.11 times 10 to the negative 31st kilograms. So the important thing to remember about this experiment is that he was able to determine the mass of an electron, and for Thomson's experiment that there were negatively charged particles, and we now know they are electrons. Okay, so the next experiment that we're going to talk about is Rutherford's experiment. So Ernest Rutherford performed the gold foil experiment, which is what we always call it. Which explained the nuclear atom. So this made us understand that the atom actually has a dense center of positive charge that's called the nucleus. Now Thomson's experiment, he hypothesized that the atom would look something like this. So if we draw a circle, he thought that this circle was a diffuse positive charge. So this entire area was just positive charge to offset the negatively charged electrons. So these green dots are electrons. So in Rutherford's gold foil experiment, he sent a ray of positively charged particles through thin gold foil. So if he had done this, all the alpha particles would just go straight through. If J.J. Thomson's model of the atom was correct, so they wouldn't be hitting anything or being deflected. But in Rutherford's experiment, he found that the um, the alpha particles, which are positively charged, so the alpha particles, some were deflected. So from this, so if this is the nucleus, it has a positive charge, and then let's use blue this time. So the blue dots are the electrons. So in Rutherford's experiment, this is what happened. So some of them went straight through without any problems, but then some of the alpha particles were deflected. So that means that they were hitting a positively charged area. So, um, and the reason why is so positive would deflect positive. So remember, opposite charges attract. Okay. So from this, Rutherford also stated that the electrons then travel around the nucleus at a distance that's relatively large compared to the size of the nucleus itself. So the important thing to remember from Rutherford's experiment is that he discovered that there was a nucleus in the atom, which is a dense center of positive charge, and the electrons move around the atom, or around the nucleus, inside the atom.